To figure out electron configurations, we need to remember the three rules. The first rule is the off-bow principle, which says we're going to add electrons one at a time to the lowest energy orbitals available. Well, if you can draw this little chart on the left here, that will give you what the lowest energy orbitals are. So when you get your paper, what I would suggest is write 1s and then 2s, 2p, 3s, 3p, 3d, and continue on. And notice, if you go at angles, diagonals, this will give you the lowest energy orbitals available. So I've got one done for you. And if you follow the red lines, you'll notice the 1s orbital is the lowest. When that is filled up, then you go to the next lowest one, which would be the 2s orbital. And you continue on. The next lowest is 2p and then 3s. Following, you get 3p, 4s, 3d, 4p, 5s, and so on and so forth. So this will take into account where the sublevels overlap. And if you just follow the red lines, you know what the lowest orbitals available are. We have to remember that there's only one s orbital, and if there's one s orbital, it can hold, according to the Pauli exclusion principle, a total of 2 electrons. Well, there are 3 distinct p orbitals, whether it's a 2p, a 3p, a 4p, doesn't matter the energy level. Since there are 3 distinct orbitals, they can hold at most 6 electrons. There are 5 different d orbitals, which could hold 10 electrons, and then 7 f's, everyone holding 2, gives you a total of 14 electrons. So, to figure out the electron configuration, first thing you want to do is just figure out your element. Well, let's say I want the electron configuration for magnesium. If you find magnesium on the periodic table, look that up, it would have a total of 12 electrons. So for magnesium, I need to figure out where to put its 12 electrons. Well, the lowest energy orbital available is the 1s, and it can hold at most 2 electrons. Once there's 2 in there, it's full, and it's time to move to the next lowest. The next lowest is the 2s, and as with all s's, they can only hold 2 electrons. So it can hold up to 2 there. I've put away 4 of my 12, so I need to keep going. The next lowest is the 2p level, sublevel, and it can hold a total of 6 electrons. So I'm adding those up. 2 plus 2 plus 6, I'm up to 10. So I need to get 2 more. After 2p, the next lowest is the 3s, and it can hold 2 electrons as well. And now I'm done. This would be the electron configuration of magnesium. 1s2, 2s2, 2p6, 3s2. Something else we will ask you is, what is the number of unpaired electrons? Well, every time you have an orbital that's full and you go to the next one, those electrons are all paired up. So all you really have to do is look at the very last one, the 3s. We know there's one 3s orbital. According to Hund's rule, they're going to be spinning oppositely. So that one has 2, one's going up, one's going down. It's considered a paired electron. So there are actually 0 unpaired electrons in magnesium. If we try another one, let's look at nitrogen. Well, nitrogen right over here, if you look up nitrogen from the periodic table, it's atomic number 7, has 7 protons and 7 electrons. Well, where do those 7 electrons go? We start with the lowest, 1s, and it can hold 2. It's full. The next lowest is the 2s, and it can hold 2. It's now full. Go to the next one, the 2p. It can hold 6 of them. But if I put 6 there, I've got 10, and I really am only supposed to have 7 electrons. So even though it can hold 6, there's only 3 in that 2p orbital. So the electron configuration of nitrogen is 1s2, 2s2, 2p3, a total of 7 electrons. How many unpaired electrons? Well, in the p sublevel, we know there are 3 different ones, and we put them in one at a time. We don't pair them up until we have to. That's what Hund wants us to say. Equal energy orbitals give as many unpaired electrons as possible. So all three of these electrons would be unpaired. So this nitrogen would have 3 unpaired electrons. If we try one more, a little larger one, let's go with silver, Ag. Well, silver is right here. Looking up its atomic number on the chart, it would be 47. So I just need to follow this chart until I've used up 47 electrons. My lowest one right there is the 1s. It can hold 2. My next lowest is the 2s. It can hold 2. My next lowest is the 2p, which can hold 6. I'm up to 10 electrons now. My next lowest is the 3s, and it can hold 2. Followed by the 3p, which can hold 6. Followed by the 4s, which can hold 2. I'm now up to a total of 20 electrons. After the 4s, the next lowest is 3d, which can hold 10. So I'm up to 30 electrons. After the 3d, we go to the 4p, which can hold 6, which is 36 electrons. After the 4p, we have the 5s, which can hold 2. So I'm up to 38 electrons. Then I go down to the 4d, which can hold 10, but I only need 9 more to get up to 47. So in the 4d, there are 9. That brings me to 47 electrons. So this would be the electron configuration of silver. How many unpaired electrons? Well, if you look at our last sublevel, there are 5 d orbitals. 1, 2, 3, 4, 5. Now I got to start pairing them up. 6, 7, 8, 9. It looks like there is 1 unpaired electron. So in red is my electron configuration. In blue tells me how many unpaired electrons there are.